Okay, so this is the third video looking at the one-way ANOVA, the relationship between noise and memory. So in the previous videos, we calculated the basic ratios. My formula wiped off here, and we calculated the sums of squares. So in this video, we're going to start with the mean squares. So in the ANOVA, the step after the degrees of freedom is what we call the mean square. In the ANOVA, that's the term that we use to refer to variance. So the mean square is just a fancy way of referring to variance. And remember, the formula for variance is sum of squares divided by degrees of freedom. That's kind of the general formula for variance. So in the last video, we calculated some sums of squares, we calculated some degrees of freedom, so now we are going to calculate our variances. The first variance we're going to calculate is our mean square A. And all we're going to do here is we're going to match up our sum of squares with our corresponding degree of freedom. So our mean square A, the formula is sum of squares A divided by degrees of freedom A. So our sum of squares is 62.5. Our degrees of freedom A is 1. So the mean square A is 62.5. And remember, A, the mean square A, sum of squares A, degrees of freedom A, all this stuff with the A is referring to the between subjects or the between group business. So A is where we're looking at the treatment effect plus error. Our next mean square is our mean square S over A. We're going to do the same thing we did up here. So we're going to take our sum of squares S over A and divide it by our degrees of freedom S over A. So in this problem, we've got 14 divided by 8, and that equals 1.75. Okay, so technically we could calculate our mean square t, but customarily we don't do that in the ANOVA. Things don't add up, we really can't use it for anything, so we're not going to take the time to calculate the mean square t. We've got the mean square A, and we've got the mean square S over A, and there's really no check that we can do at this point. So both of these numbers should be positive, or zero at the smallest, but we shouldn't have a negative number here. But in terms of things adding up, in terms of things being bigger, there's really no way of checking at this point. You just have to trust that you did the checks earlier in the problem. So once we have these two mean squares, we are finally ready to calculate the F ratio. And if you remember how I described the F ratio before, I said that F was our between subjects variance divided by our within subjects variance. And remember when we talked about variance, we said this was the treatment effect plus error divided by error. All right, so that's kind of the abstract part of it. Now let's do the actual work. We now have a mathematical representation of our between subjects variability. It's this mean square A. And we have a mathematical representation of our within subjects variability as well. That's our mean square S over A. So the formula for our F ratio is simply the mean square A divided by the mean square S over A. So we're going to plug these numbers in. 62.5 divided by 1.75, and that equals 35.71. 35.71. And that finally brings us to the last calculation step of this problem. Now, before we end, there's one more thing that we're going to do. Whenever we do an ANOVA, and that's regardless of whether it's a one-way ANOVA or one of the other ANOVAs that we're going to cover this semester, we do something at the end, which is called the ANOVA summary table. And if you've ever read a research article where they do an ANOVA, if you look in the results section, you might see an ANOVA summary table because this is the standard way of explaining the results of your ANOVA. So The first column in this table is called source. The next column is SS for sum of squares, DF for degrees of freedom, MS for the mean square, and F for the F ratio. So this is a simple 5-column table. So for the sources are A, S over A, and T. So what exactly are these things referring to? Well, A, S over A, and T, these are the little subscripts that you can see on these calculations as we move through the table. But just a reminder of what these things are. A is our between subjects. S over A is our within subjects. And T is our total. All right, so that's essentially what those 3 rows are referring to, our between subjects, our within subjects, and our total. So once we have the shell of this table put together, once we have the columns and the rows labeled, all we're going to do now is fill in our calculations. And if you did things in order the way I did them, it's really just a matter of going through these calculations in order from start to finish. So for our sums of squares, our sum of squares A was 62.5, S over A was 14, and the total was 76.5. Our degrees of freedom were 1, 8, and 9. Our mean squares were 62.5 and 1.75, and our F ratio, which we're going to put in the first row here, is 35.71. The only other thing I sometimes do with this table is I draw a line here to divide the total from these first couple of columns. And this is just a reminder to me to make sure that I added up the sums of squares. So 62.5 plus 14 should equal 76.5. And also the degrees of freedom. 1 plus 8 should equal 9. All right, so that is an ANOVA, a one-way ANOVA, all the way through to the ANOVA summary table. Now, some of you may be wondering, what does 35.71 mean? Well, we're not quite ready to cover that yet. We're going to work on that next week. For now, I want you to practice, and I'll probably put at least one more video series up here so you can see me work through another problem. For now, I want you to practice doing the ANOVA calculations, getting through to the ANOVA summary table. All right, so we'll have another video sequence up here so you can see another problem with some new numbers. But that's it for now.